me know when. All right, my name is Jimmy. This is James, and I have Kate beside me here. We are software engineers, and we're going to take some questions.
Okay, why don't we just start with some of the recent questions from the forum, community.wemotion.com, which is also a great place for you to ask questions in general in your daily life. James, do you want to talk a little bit about STK hangs and crashes?
Sure. Yeah, there was a recent post. In our SDK, it was a C# developer is having a hang on exiting their application and doing the cleanup. And this is, so for some context, there are a class of issues like this in different languages which we've experienced since our very first SDK, and we've cleaned up a lot of the hangs. Exiting a program is something that can be does not get tested as well as starting the program, and a lot of developers sidestep that by doing a quick exit out of it, so that good developers who do the proper cleanup can catch some of our bugs. So we've been cleaning those up. In fact, our next release will have a fix for hanging when the service is unreliable. As for this C# issue, we'll have to debug it directly. For workarounds in the meantime, you can work around it by not being a good citizen, or not necessarily disposing of your listener and controller, and then exiting using the forced exit mechanism. But yeah, we'd like to have a better solution for that. So hopefully the next SDK will fix that. If not, we'll with more information, we can probably, such as a binary or some code samples, we may be able to debug it in-house.
We might also be able to do live debugging, like join me in, that kind of thing.
Mm-hmm. Yeah, that's true. Yeah, our engineers here, if you set up a session using join.me or TeamViewer 8, we can log in, and engineers as well as our QA people can also troubleshoot and debug.
Can you talk a little bit about, there's been a lot of interest lately about Unreal Engine plugin. Can you talk about sort of what's been going on with that, sort of any developments you've seen in the forum or internally at all?
Yeah, I can speak a little to that. We know that there's a pretty large group of people on the Unreal communities that have been trying to integrate with Leap. And in order to respond to that, we actually have an engineer in-house who is working with the people at Epic Games to develop a plugin. And so we're still in the process of architecting it out. And at this stage, nothing is finalized yet. We're kind of using what the community has built as a starting point and hopefully making something that is both flexible and powerful. I don't know if you've, as part of the community, I've talked to Adrian. He's Adrian Dazinski. He's part of the effort here. So he's working on that.
This is actually a really common one. Improvements to range. What are we doing to sort of address range issues, especially for VR developers? What are your thoughts on that, and just sort of any lessons from the trenches you can pass along?
So with our VR launch and V2 and recent tracking updates, we've definitely pushed to probably the 40 or 50 centimeter range. And for most VR applications, that allows you to stretch your arms. Like if you're wearing an Oculus Rift, the Leap is a bit in front of your face, so even if your arms are all the way stretched out, you can basically track your hands at that distance. Sometimes it's not actually the distance that is the biggest factor. It's how far it is from the Leap and how far it is from the background. Because the background, if it's a very bright object, like a wall, can actually be as luminant as your hand. So our device will have difficulty trying to tell the hand from the background. Usually this happens when you're sitting down in front of your computer, you have a monitor, and you're facing forward, and if you're trying to if you're trying to open an app and you're manipulating an object in front of you, sometimes your hand will actually go as far as touch your monitor. Those are the cases that we have the most difficulty in right now, because it involves harder image processing to try to find your hands from the picture. But we're still trying to improve our algorithms even in those cases, and so in the coming months, as we release more software updates, you should generally see an improvement.
So since we're software-based, the tracking, people report the tracking sort of varies from release to release, and a lot of times it's just adapting to certain changes, and so we get a lot of questions about sort of inconsistencies in tracking. Can you guys speak to sort of ways as a developer to not only just adapt to these subtle differences, but sort of ways you can anticipate them in your code at all?
Are you talking about like regressions in the tracking?
Not just regressions, but even just changes. Like, are there any ways you can speak of, or just in general, sort of like how to deal with any inconsistencies you might find?
Well, it depends on what the app does. So for every app, you just test the functionality that you've coded. Make sure that if you upgrade to a new SDK, that all the intended features still work. Sometimes we have a change log that lists specific cases that have been improved or that work a different way. So for example, as a really major change, when we moved over to skeletal tracking, we always have 5 fingers now. So if your app depended on fingers disappearing to actually trigger an event, then that action will no longer be possible due to an actual improvement in the software. And in other cases, if we make the motion smoother and you were using how fast something was moving, then maybe by changing our algorithm, we inadvertently affected your behavior. It's a combination of just looking at what the actual release notes say and comparing that to the behavior and possibly changing the thresholds to match the new behavior.
So both of you guys have created applications using Leap Motion. Can you, for instance, Jimmy, you created the VR intro, which maybe some of our viewers have tried out at our various events or just at home with their Oculus. Can you run us by sort of the thought process behind that and the steps you took sort of design-wise and any hurdles you encountered that were notable?
Well, design-wise, it's really a basic design because it has to run on most computers, and there really wasn't that many resources given to like making a full-fledged application. It was the minimal set of work that needed to be done to prove a point. The point that Leap was a great input device for VR, and so the thought behind it was there's some major categories of interactions that you can use Leap for. You can use it to like physically touch and grab objects. You can use it to make motions or trails with your hand, and those cause a certain behavior to happen. Or you can also use it to change the point of view, change the vantage point that the scene is drawn from, basically camera control. And so there was a stage in the VR Intro app that demonstrated each of those things. So for physical interactions, you can grab balls. For motion, there was like a star manipulation level, and then for camera controls, you could fly through space by changing your hand. And that was pretty much it. Any further work probably would have had diminishing returns for this project. As for challenges, probably the biggest challenge is still performance. It's hard to It's hard to run such graphics on computers that don't have a good graphics card, and so the next updates will probably address that.
So we have a question from the chat room. It says, "Hi, I've been hoping to do an Oculus/Leap style combo with Google Cardboard/Android. I've seen Android and Leap done. What does it take?" James, you want to field that one?
All right, thank you, Genkihara. Okay, it's a great question. So it sounds like you're looking for a cardboard demo. So here is a cardboard with a Leap attached using the Oculus mount that we sell for $20. Well, as for what it takes, I'll give roughly 5 steps. First things first, I think, would be to get your hands on the Leap Android SDK. You can email developers at leapmotion.com and request access to that SDK. It's currently now for release. It's certainly a Leap. Ideally, you should have a mount too, but if you can lose something and avoid covering the sensor, it's okay. And you should probably get a cardboard or cardboard-like head-mounted display. Now, in addition, one more piece of hardware you need besides cardboard and the mount is an adapter like this. This is a USB-A to micro USB adapter. Now, the phone here. This is like a Nexus 5. So yeah, typically there's an OTG port that you connect through. So you can plug the adapter in there, and then connect your Leap through that adapter. And just like on the PC, yeah, we can communicate through USB. This example here, this is running the flower demo, which you can't really see because it's running bright. So I think I covered big steps 1 and 2. Step 1 was get your hands on the SDK. Step 2 is get all necessary hardware, including your supported phone, a dongle, cardboard, and a mount. Okay, then you'd like to start building your app. So maybe the first thing to do would be run our sample apps. And we include in the SDK, we include a number of examples, including at least one cardboard example is included. I think it's called Leap Dive Hand Viewer. So it's just a typical hand visualizer. And then you want to start making your own apps. Now, in our experience, the easiest way to make apps for Android is to build them in Unity, because that's how a lot of our apps on App Home are built in Unity. And the main thing you do is once your DL is in the right place, you hit export, and often your program will just work out of the box on Android. And yeah, that's kind of how we made a number of our early demos, such as say using the playground. Now, I think I've covered 3 or 4 steps for getting things to work on Android. For Cardboard, you need an SDK that deals with the head-mounted display. So from there's the there are a couple of ways to do that. Right now, one of the most popular Cardboard SDKs is the Dive SDK. That's made for a head-mounted display that actually came before Cardboard, but functions much in the same way. They showed at Oculus Connect that for some time Oculus has been working on an SDK for the Gear VR. Their attempt at a head-mounted display for Android. For that, you wouldn't be able to use a generic phone like the Nexus 5, but if you are in the, say, Gear VR developer program, you could use their hardware. And once you start developing on Cardboard or just Android in general, I think the biggest issue will be the performance. On a good phone, you may be able to track one hand at about 60 frames per second, but things get worse once it's 2 hands or if other things are running. And that's one reason the SDK is still in alpha. So we're working on that. And one of the steps towards getting to beta is to improve our performance enough to run on a decent phone. Other challenges might be just, it is different in mobile VR is somewhat of experience from desktop VR. But John Carney likes to highlight the benefits. I mean, for one, you can share it. And if you want VR to really touch the next billion people, it's just great. You can just give something to someone, you just try it on, and try to give it to the next person rather than having to hook up all your cables. And another benefit is you can just turn all the way 360 degrees around in your swivel chair or whatnot, which you can't really do if the cables attached to you that would choke you. Anyway, Genkihara, I hope that answers your question.
I'm really curious about Android. I was wondering if you think that what do you think is deficient if you use Android or mobile over, like, say, Oculus? Like, in terms of experientially, like, a lot of people say that it's not as satisfying. What do you think it's going to take to build experiences to get it to that point? Because you're right that in order for VR to be widespread, we need robust mobile support.
Mm-hmm.
But what is that sort of like? How do we break down that fourth wall for mobile, in your opinion, or where do you see that going?
There's I've been late to the game on the discussions of mobile versus non-mobile VR. There's I mean, I think the main disadvantage to a device like this is it has much less computing power than a modern PC. Probably at least 2 years behind. That said, it's pretty amazing what it can do. This one contains a Snapdragon processor. We now have tablets with Tegra K1, which is that GPU, which I worked on in my previous job, has as much horsepower as the MacBook that came out in 2012. So it may be a generation behind the PCs, but even that previous generation was pretty amazing. And that's for graphics. CPUs or quad cores, or even some phones have octa cores, like the Exynos 5 octa architecture. So you may not be able to play modern games of now, but to play games of 2 years ago. And VR has been going on for 30 years or so, and a lot of those games, even in the past decade, have been fun. Well, even before that. I think John Carmack's keynote at Oculus Connect really highlighted how there's a lot of hope for mobile VR. There's the benefits, the things you can't do in real VR, like sharing. Often, really, what should be given isn't the highest end graphics, but making something fun. And you don't necessarily need the latest and greatest cinematic graphics to make something fun or usable. Even for applications of, say, one of the best apps I like in Cardboard is the home theater. So that's video. It's not Blake's game, but it's video. It's YouTube. Or things like maps and navigation. So they're capable of giving an experience for people, even if without the latest GPUs. And on top of that, I don't have the Gear VR here, but its resolution is about twice that of the DK2. So mobile phones with their large screens and pixel density, in some ways, are set up to do to at least track with a desktop VR experiences. Other benefits include that although desktop GPUs have been designed to have a lot of horsepower, they're designed for queuing up a lot of different work. And with VR, what matters a lot is latency. So desktop GPUs actually aren't that far ahead in minimizing the number of milliseconds from rendering to your eye. So I think it's a combination of things. We have one factor against mobile VR, but I think there's a lot of factors in favor of mobile VR. So quite hopeful of things like Cardboard or VR or whatever comes after that.
I think it's really what you said about how VR has been around for 30 years is really important. I think it's something that our generation really tends to forget, that we're just one part of this puzzle. So it's important to kind of sort of note our chronology and this whole thing. We had another question about JavaScript. And while we don't have our JavaScript #1 JavaScript dude with us here today, you guys, I'm sure, have enough familiarity to field this. So I've been working with mobile Chrome and 3JS. Does the Leap JavaScript work with mobile Chrome?
Yeah, so I got this question from a guy named Keen at Autodesk. I don't suppose you know him or happen to be him. Can't get out of. Initially, great thing about web apps is that you write them and they can run on Windows, Mac, Linux, or Android. So we did a bit of initial testing on Chrome for Android. In fact, at that time, the dominant browser in Jelly Bean was Android browser, and they were switching over to Chrome for Android. But now I think in KitKat it's pretty much all Chrome for Android, which supports WebSockets. So since early on, we've been able to run in Chrome for Android. One problem, though, is that in keeping up with these web standards, we've made our WebSockets more secure. Instead of using regular WebSockets, we're now using WebSocket Secure with the TLS security layer. And we've got that working in Chrome, mostly working in Firefox, working for Internet Explorer 11. But not fully working on Android. There's issues of making that certificate properly signed and installed on an Android system. But in the meantime, you can work around with that. You can use our old LeapJS, which uses the insecure certificate, and I believe if we hack around a bit, we can just install a certificate on your phone, and probably using one of those certificate programs on the on the Play Store, and hopefully it'll work. Yeah, well, we'll be happy to work with you to get that working. It shouldn't be a lot of work. It just hasn't been a priority since right now we're kind of focused on a number of things in Android, but particularly VR, and haven't focused so much on web apps there.
Do you guys think web apps are going to be an essential part of the VR puzzle, or do you think that JavaScript, 3JS are going to be important components, or do you what's your preferred language in VR? Like, what do you like to build in?
Well, so I guess our preferred language isn't as important as what the community's is. And if you look at HTML5 and 3JS and all this developments, it's clear that the trajectory is on the rise. And so any app, any ecosystem that involves VR will probably benefit from having JavaScript support. And so we realize this, and so we will continue to support JavaScript. Like C++ is personally my preferred option, and we have a few other people in-house that like to develop in Unity, and we have a couple of JavaScript people too. But I think the less startup time you require, just the massively more people you can reach, and in some ways JavaScript is even less of a hassle to get started than Unity. So if you can imagine just going onto a website and clicking a few knobs and suddenly you've made your app, then that's the level of ease that you need to just get it to everyone.
What do you love about C++ though? If that's your preferred language, I really do want to know.
The reason why I like it is once you get all the bugs out of the way, once you get it to compile and cross-platform get it to work, then it has the best performance. So even as hardware increases, that's always going to be true, but it is a hassle to get to that point. So it's only appropriate for projects that have a wide distribution, that have a lot of resources that you can afford. And yeah, it really depends on what the needs are.
Can I say something?
Yeah, go for it. Yeah.
Okay. Yeah. So with respect to VR in particular, C++ versus Unity versus JavaScript. I think I can quote John Carmack a third time in this switch. When they first released, say, their mobile VR SDK, their examples, they didn't want to call it an SDK. They designed for low latency, and these are C++ examples, heavily tuned. But really, a lot of developers say, I'm using Unity, I won't touch that. Then there's a dilemma. Latency is really important, and eventually, we took a while to get our Unity SDK or Unity assets in order. But yeah, it makes the job a lot easier. For VR in particular, there's still challenges, like a single garbage collection can make a stutter or judder that can really ruin the experience. But overall, the trade-off is well worth it to reach the bulk of our developers. Now, when you go to JavaScript, I think we're at a point where we're not quite there for matching latency requirements, since you have even more layers at this time. So the current technology, it probably has a lot of disadvantages for even for regular users, because even regular users, to reduce headaches, you want to keep your latency as soon as you turn your head to a minimum. But I think over time that those issues will be overcome. I mean, we have a lot of technologies in the browser to speed things up. We've had WebGL for a while, but there'll be similar technologies for more direct rendering in the browser. So Android is currently triple buffering in the OS, and there's probably some other layer there. But as we move to front buffer rendering, that helps a lot. And I think browser technologies will probably soon have some things that can reduce the latency from movement to your eye. And once those are widespread, yeah, JavaScript will be able to reap its advantages for just being even more easier to get started than Unity.
I'm going to ask you guys a potentially polarizing question. I'm not sure if you have a distinct opinion either way, but do you think the future is more in AR or VR? Because I've heard both arguments for both, and I think it's a really interesting question. I personally am way more intrigued by augmented reality, and I can't exactly tell you why, but I under the impression that a lot of people are really interested in that too. Any of you have a distinct opinion either way?
So, I'm inclined to mostly agree. I think that like VR is just AR with a certain setting, right? You just turn reality off or turn it on. But I would say AR is the encompassing like overall technology that can and should be achieved. Like once you can make like your own world more useful or more meaningful, then you can talk about existing in some other realm. I think that's the word of importance there.
I think David was asked it at a recent meetup, and he said it was a tough question. I think he was declining to predict the future because no matter how smart you are, yeah, predicting the future isn't something people can really be successful in. So I'll decline to predict the future on which one it'll really be. I think AR can mean a lot of things. Like there are apps on these smartphones where you can use the camera in there, and yeah, and even with Leap you can even interact with some of those things. But a lot of initial AR-like things in VR have been they use the camera on the phone, and they can put it with say their VR app, and but the camera on the phone is this really small field of view camera. So some mistakes you'll make that just blow that image up. So then you've actually taken it away from reality because this is not a wide field of view camera. So one thing that we believe about AR is that if it does take off, it's not going to be using these kinds of cameras. It's going to be using things like our camera, these wide field of view cameras, which you can access now with the image API. With a prototype Dragonfly with color, that's certainly closer to reality. So yeah, I believe if AR does take off, it'll be in a form that people need to realize that it's not those tiny cameras or tiny field of view cameras on the phones.
Yeah, it'll either be like you could have true transparent displays, or technologies like James described, where like you have very, very accurate cameras. Basically, the less noticeable it is, the more it is to the kind of AR that will be most useful.
So I want to maybe shift gears a little bit to another top question that we face in terms of the UI UX arena. A lot of people are interested in productivity and OS control applications, and I guess you could maybe discuss, because we've just started with our VR widgets that we just released, exploring what OS control in VR means. And I guess maybe could you talk speak a little bit to how OS control with incorporating Leap Motion technology for the desktop is different than in virtual reality, and maybe some interesting findings that you encountered when exploring the possibilities there.
Well, with virtual reality, it's definitely easier both to develop and to use, because like Leap and all Leap controls, they are obviously in 3 dimensions. So if you only have 2 dimensions to experience it, then you need to use kind of gimmicks. For example, you can use a circle to indicate how close you are to a certain plane, or you can use, or you can just like project your hand, your fingers to some surface or something. But having the number of dimensions match means that you don't have to second guess yourself. You know something is like physically in this location, you can just grab it. And as long as obviously the calibration is good and everything's been aligned, then you will get it right every time.
James, any thoughts?
I agree with Jimmy.
You concur? I guess maybe we had a couple of questions about sort of Linux, and maybe James, you can speak to Linux. I know I personally bug you with a lot of Linux questions. Do we ever plan to support Linux to a higher capacity than just developer, or what do you think? What do you see? I know you mentioned here that we've encountered some C++ and Linux issues, so I don't know. Can you speak at all to Linux and sort of the current roadblocks and the state of things?
Yeah, sure. Okay, so I think we released the Linux SDK in February or March of 2013, so before our consumer release. It was, yeah, from the developer community, it was probably one of our most demanded things, like a post with like 100 responses where people just say +1, please, I must have a Linux SDK. So we were answering a lot of fan demand there. That said, it was still an experiment to see what people would do with it. So we never added Linux apps on the Motion App Store. But we're open to that if a lot of great Linux experiences were built using our technology. So far, it seems to be, by far, developers are Linux users. And that may be why we don't yet support Motion App Store. That could change over time. One set of consumers we were investigating, and we have articles on, say, recently about high fidelity, which is sort of a descendant of Second Life. And we learned is that most Second Life users were running on Linux, and that seemed like a great application. There's multiple viewers out there, but yeah, Second Life, you want to be in your virtual world and you want to be able to express yourself with gestures. I don't know if we have enabled any public clients now, but we do. But the article about high fidelity says they're definitely playing with that, and high fidelity is very much like Second Life. I don't know if there was Linux focus, but that was when we sort of looked into would it be a consumer thing. And once we paid attention to that, that drew us to other issues like, do we run on every Linux or just the latest Ubuntu? Currently, we really only run on Ubuntu 14 or 13 or 12, because those have much more the market than say, Fedora. But yeah, that could change over time. I think the best way to push us to do more Linux support would be to make some really great, compelling experiences on Linux, like Second Life or maybe something else, but something that really demonstrates the power of technology on Linux.
Can you speak at all about the Unity 5 or in general supporting new versions of game engines or development engines like Unity? What's the, what can developers expect in terms of the turnaround there? I mean, should they, if they have an engine that they love and they really want Leap support, should they request it directly, or what's the best path? How would you advise people who want support?
Okay, so a few questions there. One was about Unity 5. So Unity 5 is in beta. It adds a number of features. It's just like a 64-bit editor on Windows. Yeah, when we played with it here, in my experience, it just works fine with our SDK. But there are some hiccups, as pointed out in the forums, like, say, for Windows users, the 64-bit editor will doesn't play well with our default plugin, which is 32-bit. So we're looking to package this properly such that it'll just work with either editor. And yeah, we prioritize that based on demand. Unity 5 is still beta, but you can be sure that before it becomes the non-beta public release, we'll have that sorted out in one of our SDK releases. Other engines, we can't support every engine out there, but what we can do is we have bindings for C++, C#, Java, Python, and other bindings can be built. So yeah, I think things like Unreal Engine is C++. So even if we don't have a solid Unreal Engine plugin like the Unity asset we have, users can just use their API directly. And I think that is what happened initially with the Unreal Engine 3 plugin. I think even before the plugin, we just had apps using Unreal Engine 3 because of the developer just, he just hooked up to our C++ API. And yeah, for engines that may not be as popular. Let's say the Torque in an open source MIT license engine. What happened is there was an enthusiastic developer on the forums who posted their plugin, and it's on GitHub. So the first thing to start with, I think, is maybe ask on the forums in case someone's already done that, because there are a lot of engines out there, and you may not get a GitHub repo with a solution, but you can often get advice on how to do it. And yeah, worst comes to worst, you can develop it yourself. Yeah, so.
And I guess we only have a few more minutes here, but to close it out, I wanted to ask you guys, you know, if you look on YouTube and Vimeo every day, we see awesome projects coming in all the time, especially with our 3D Jam, Indicate 3D Jam heating up. Can you guys think of any projects you've seen in the wild off the top of your head that you've just been blown away by, really impressed by? And can you tell me why?
The anatomy one, I really like that one.
Frixius?
Yes, Frixius.
Yes.
I think that was.
Can you explain a little bit about what that demo was?
Yeah, so you're in a lab, and so this is a Leap plus Oculus Rift demo. And so you're in a lab, you have a full life-sized skeleton in front of you with all the organs. And at first glance, it actually looks a bit grotesque, but it's a really good learning tool. You get to see, like, this is actually what anatomy is. You can grab, like, a brain and you can pull it out. The gestures that the guy made, he didn't use, like, we actually were trying to do similar interactions in-house, and this person independently made a few pretty solid ones. You can, like, grab something, and once you move it close, you're suddenly in the brain. You see neurons, or you see you're in the bloodstream and you see cells. The experience is really well done. And also, what I liked was there's a panel that floats in front of you, and like, you have settings, and you have a scroll bar with a text, and all of that was pretty easy to use with just your fingers. It was one of the first examples that I saw that was actually easy to use.
James?
Yeah, so as I work on Android stuff, I largely enjoy seeing some of the Android projects in the forums. This could range from a Believe Accelerator. There were a couple projects there, like the sign language translator or GetView's augmented reality solution that run on Android. I think there was at least one recent cardboard post. Yeah, anything that ties into that impresses me. One thing related to our V push has been the image API, and I think it was just a couple days after that someone released a kit for detecting retroreflectors in our API. Yeah, anything that relates to VR or Android, I love seeing that in the forums.
I think we're going to wrap up here in a few minutes. Do you have any last parting words of wisdom for our viewers?
So I guess so a lot of these developers are just getting started with their game jam projects.
Yes.
Okay. If you're having trouble with just geometry, like getting Leap data integrated with the Oculus Rift, like getting positional tracking working and all that, I know that I personally have had some frustration there, and most people who do it for the first time generally have to do a few iterations. But if you go on our developer blog, we actually have some good tutorials there that will tell you our recommended way of building a Leap app with Oculus. And it can also apply just a Leap app with general VR. So it'll probably help to look at some of the code there.
James? Any last words of wisdom for our viewers? 3D jammers?
I never answered the question of what language I primarily develop in. Our platform is primarily C++. So
Can you actually just, I know I kind of asked Jimmy about this already, but maybe you can dig a little bit deeper why C++ is so key for us from the beginning.
Yeah, I agree with Jimmy. It's largely performance. Another quote, Barney Strustup. He asked like, what is he doing for greenhouse? For saving the planet and the greenhouse gases. And yeah, he makes C++, and that makes the world more efficient. A lot of Google runs on C++. So yeah, when performance matters, such as in our tracking algorithms, we use C++. It wouldn't be usable if it was in Python. So that's a trade-off, and you're often trading off developer time for runtime performance, and often that's the right trade-off to make, especially if you're running on Google services and 2% of the greenhouse emissions are Google's data centers.
You saved a lot of coal by doing that.
So
C++ saves
the planet, yes.
I did not know that.
Now, but of course, we need time to develop things, and if it takes 10 years to develop your program that would save the planet, then you delayed saving the planet by 10 years. So stuff like Unity can get you there faster, and stuff like Python can get you a lot of things quick and dirty. A lot of our internal research stuff is done into things like Python or MATLAB because we want to know the math before we code it. So what I code in, whatever needs it, a platform needs C++. A lot of our Android examples work best in Unity. I've done one game interface for a Nintendo game in Python because it was quick and dirty. And I'd encourage all developers to do whatever makes you most comfortable. If you're already in an engine that's in Java or whatnot, stick with that. We can make Leap integrate with that.
That's about it. Thanks, guys. All right.
Thanks a
Feel
lot,
free
guys.
to go to community.leapmotion.com with any follow-up questions. Look forward to chatting more.